Okay, so the checkpoint that is due today, here is the first question. Draw a line segment. Let me see if I can zoom in. Oops. We can see it better. Okay, draw a line segment with endpoints M and R. Now draw a parallel line segment that is the same length as segment MR with endpoints M prime and R prime in the same order. Which answer correctly describes the transformation from MR to M prime R prime? So if we sketch a picture, here's our segment. We have the endpoint M and the endpoint R. So that's the first step. Now they want us to draw a parallel line segment that is the same length and label it with endpoints M prime, R prime. So we have the pre-image and then we have the image, and it looks like we're just sliding it down. So which correctly describes the transformation? Is it a reflection, a rotation, or a translation? I'm gonna let you take a look at it and then let me know. Send me in the chat. What do you guys think? Do you think it's a reflection, a rotation, or a translation? So remember, a reflection is a flip. A rotation is a turn, and a translation is a slide. Yep. And so I'm getting it in. Yep. We're just sliding it down. And so a translation would be the correct answer. All right, next question. We are going to use this graph to answer the question. Triangle ABC is reflected over line L. So here's our line of reflection right here, the black line. To result in the image triangle A prime, B prime, C prime, which statements are true about the transformation that maps triangle ABC to triangle A prime, B prime, C prime? So select all that apply. So the transformation is a rigid transformation. So a rigid transformation means the size, the angles, the shape, it doesn't change, right? We're simply picking it up and moving it. So yes, this is a rigid transformation. And then the angle measures remain the same from the pre-image to the image. Yes, that's correct too. Because if it's rigid, then that means the angles stay the same. Yeah, sorry about that, Sarah. They do. They like to shuffle the answers. So yeah, don't check them in the order that I'm checking them. Make sure you find the same one. So find the box that says the transformation is a rigid transformation. And then the one that says the angle measures remain the same from the pre-image to the image. The transformation is a non-rigid transformation. So we already said it's a rigid. The non-rigid would mean that it's like stretched or it shrinks, which in this case, it did not. It's the exact same size. So it wouldn't be non-rigid. The side lengths remain the same from the pre-image to the image. Did the side lengths remain the same? Well, AB, well, we don't know that one, but BC is 2 and AC is 2, which means AB is going to be the same. So we can say yes, that is true. The angle measures do not remain the same. We just said that they did. So we can see that angle C is a right angle, and it just really looks like they just flipped it, right? They reflected it across the line, which means that the angle stayed the same. And the side lengths do not remain the same. We just said they did. We checked and they did. So it looks like those would be our 3 answers. I'll give you a second before I click next. Any questions on this one? All right, let's go on to the next one. Use the graph to answer the question. Which answer correctly describes the transformation from the pre-image to the image? So go ahead and take a look at this graph. Tell me, is it a reflection over the y-axis? Is it a rotation of 180 degrees, a translation 10 units right and 8 units up, or a reflection over the x-axis? So did it flip? Remember, a reflection's a flip. A rotation is a turn. Did it turn? Or did it slide for a translation? Did it slide 10 units right and 8 units up? So, yep, some answers are coming in. You guys are correct. It's a translation. So a reflection, remember, it would have to be a mirror image. So in this case, these are not mirror images. So we know it's not that. A rotation, it would be turning. So the image would be turning. It wouldn't be facing the exact same way. So then we know it's a translation. We just slid our pre-image, this triangle. We moved it 10 units right and 8 units up. Even though it should be, oh, it's this one, 10 units left and 8 units down. Oh, they tricked us. Sorry, we didn't see those last two. And you guys got it right that sent it. It would be 10 units left because here's the pre-image. So it's 10 units to the left and 8 units down. Make sure to click the right one. Those both look the same with the 10 and the 8. So 10 units left and 8 units down. Any questions on this one? Okay, didn't have to write anything down. The following graph shows A, B, C, D, and A prime, B prime, C prime, D prime. The following mapping statements describe the transformation of the vertices of the quadrilateral. Which function rule correctly describes the transformation from quadrilateral ABCD to A prime, B prime, C prime, D prime? So from our blue square to our pink square, what are we doing to the X values and what are we doing to the Y values? So you can look at the graph and determine that, or you can look at the points that they gave us to help determine that. So point A went from -3 for the X value to -1 for the X value. So it looks like we are, and then for B, it went from -2 to 0. And then for C, it went from -2 to 0. And for D, -3 to -1. So what's happening to the X values? We're adding 2. So we're adding 2 to the X values. And then now let's look what's happening to the Y values. We're going from 2 to 0, from 2 to 0, 1 to -1, 1 to -1, which means Sarah's correct. Yes, we are subtracting 2 from the Y values. And you can also just look too. You can look at C here up on the graph to C prime, and it went down 1, 2. And then you can also see that we went to the right 1, 2, which is why we added 2 to the X. So when you move to the right or up, it's plus. And then if you move to the left or down, it would be minus. So let's see, it would be this one. And again, check where yours is. The answer choices are scrambled. Any questions on this one? I think this is actually number 4, huh? Not that they're numbered. All right, moving on. Number 5. The following mapping statements describe the transformation of the vertices of triangle ABC to the vertices of its image triangle A prime, B prime, C prime. What is the correct description of the transformation that maps triangle ABC to triangle A prime, B prime, C prime? So for these, they gave you some rules, like if X was positive and then X is negative, and then if Y was this and now Y is this, there's rules. The easiest way, instead of having to remember all of those rules, is you can kind of just sketch it so that you don't have to worry about memorizing all of that. So we could sketch a little graph. A is at 0, 2. There's A. A prime is also at 0, 2. And then B is at 2, 9. And then B prime is at negative 2, 9. And then C is at 4, 2. And then C prime is at negative 4, 2. And so now we can pretty easily see that it is a reflection. And we have our x-axis here and our y-axis here. And so very good, Keegan. Yes, it is a reflection over the y-axis. And Sarah too, excellent. So a reflection on the y-axis. Any questions on number 5? All right. Number 6, the coordinates of the vertices of trapezoid ABCD are A, -1, 4, B, 0, 2, C, 1, 2, and D, 2, 4. ABCD is first rotated 90 degrees counterclockwise. So remember, counterclockwise would be the opposite way that a clock goes. And then it's translated 3 units to the right. So which graph shows the final image of A prime, B prime, C prime, D prime? So the transformed figure. So here, so I know you guys can scroll, so sorry, we can't really see all of it in one shot. And we all have different answer choices. So if it's rotating, if it's turning, right, a rotation turn. Yes, Sarah, you're correct, right. It's gonna be turning this way. So it's counterclockwise, just 90 degrees. So we know it's gonna be somewhere over here. And then it's translated 3 units to the right. So this one was rotated clockwise 90 degrees. So it wouldn't be this one. This one would have been rotated 180 degrees because now it's from up here and now it's down here. And then this one, so we know that it, like we said, it would be this first one because we're looking for it over here in this area for it to be 90 degrees counterclockwise, and then it was slid over 3 to the right. So yes, the first one. Very good, Sarah. Thank you. Any questions on number 6? Okay, good. All right, use the graph to answer the question. Which series of transformations correctly maps rectangle ABCD to rectangle A prime, B prime, C prime, D prime? So is it a rotation? Is it a reflection in the x-axis, a reflection in the y-axis, followed by these translations? So go ahead, I'll give you a second. Make sure you're starting with the blue rectangle and then describing the transformation from the blue to the green, because if you reverse it, it'll be wrong. Okay, very good. Yes, so it is, we're reflecting it first. So we're flipping it across the y-axis. And then, but it looks like it moves down 1. So that would be the third option. It's a reflection in the y-axis followed by a translation 1 unit down. So we flip it and then we slide it down 1 unit. Excellent. And that's it. Any questions about the checkpoint from today or about transformations? Okay, so you guys are done with your assignment for today. I'll stay on. I have a few more minutes before my next live session at 10. So if you want to stay on and ask me any individual questions, I would be happy to help you. If not, have a great day. Thank you guys for coming. And I'll see you next week. Thank you guys. Have a good day. All right, I think I have a few pre-algebra students for our 10 o'clock session. So go ahead.
Sorry, I had a question.
Yeah. Oh, yeah.
So I don't know if you got my message in the chat, but this is like my first week of like doing everything, because it took a while for me to like get into the academy and start, and so my Canvas wasn't really working. Yesterday when I was doing the work, I didn't realize I started doing it all the way from the beginning of the semester. And I didn't do like yesterday's. So do you want me, because I wasn't here for the first week or two, do you want me to start from the beginning or just start from like today?
How far did you get yesterday?
I don't know, maybe like a few days in until like I finally realized that I was doing.
If you're okay, if you think you can get caught up, it's best because it was just like really an introduction to geometry. It went over things that you kind of need to know, like all of that terms and then like symbols that they use. So if you can go through it, that would be great, just so that you don't have any gaps, because now they're kind of they're using all of that vocabulary and stuff that they taught you at the beginning. So it's definitely probably better that you did do it. If you feel like overwhelmed, then I can go through and excuse you from a couple of assignments too.
Okay, do I have like a time limit on when I need to finish that by?
Yeah, no, there's no we don't take away any points for being late, and if you just joined, especially not. So, but even to any student, there's no I don't know how you say it, for late work.